This video is an introduction to motion. This is the first unit in Physics 12, and it's split into two parts. We have relative motion and special relativity. Relative motion deals more with scenarios that we see in our everyday lives, like walking somewhere or watching a boat cross a river when there's a strong current. Special relativity, on the other hand, is not really something that we experience, because it has to deal with things that are traveling near the speed of light. Let's first take a look at relative motion. An example that you might be given, a simpler example, would be if someone's walking and they walk some distance north and then they walk a bit east and then maybe some distance southeast. Our goal, is to find their displacement. So the resultant would be how far are they from their original point? So how long is that distance, and also in what direction? Another example you might get is for velocity. So let's say you have a boat and you want to cross a river, and your boat has some speed directly across the river, but the water is also moving and it has some speed downstream. So our question here is from the perspective of someone who is standing still on the bank over here. How fast would they see your boat travel? And our answer would be the resultant velocity. We would want to find how fast are they going and also in what direction. As you might have noticed in the two simpler examples I gave, drawing diagrams is crucial for this unit. And I find that setting up the problem is often the hardest part. To make this easier, it's super important to know how to visualize and add vectors in 2 dimensions, because we will be doing that throughout this unit. This first video on the top talks about just that. It's an introduction to adding vectors and components of vectors, so I find it to be quite helpful for understanding what we will be doing with displacement and velocity vectors in class. You'll notice that the math used in this video involves trig functions, and we will be using sine, cosine, and tangent functions very frequently in this unit to find components of vectors and directions, so make sure to review that if needed. Some more complicated problems actually involve sine and cosine law as we move away from right-angled triangles. So I've linked to more of Khan Academy's videos if you're not too familiar with those. The second part of motion is special relativity. And in this part of the unit, we explore what happens as things travel near the speed of light. Let's think about this for a second. Imagine there's a rocket that is so powerful that it can travel near the speed of light, which is 3 times 10 to the 8 meters per second, which is super fast. And you're sitting on the ground, you're not moving, and you're just watching the rocket. Our question is, what do you notice? And the answer to this seemingly simple question is actually quite weird. Things that we think are constant, like time, length, mass, they all start to change. And what I mean by this is that what you observe as a stationary observer will be different than what the person in the rocket experiences. And this is a really hard concept to wrap your head around because we don't normally see this in our everyday lives. And the reason for that is something called the Lorentz factor. The Lorentz factor determines how dramatic these differences are between what you observe and what the person in the rocket experiences. It depends on the speed of the moving frame, or the rocket in this case. So the faster you go, the bigger the difference there is between your observation and that of the person in the rocket. And since we can't go nearly as fast as we need to see these relativistic effects in our everyday lives, these changes are not intuitive to us, which makes them very difficult to understand. We'll get more into the reasoning behind special relativity later, but what we have to do in this unit is to do some simple math to find the differences in the stationary frame and the moving frame. The math that we have to do is mostly straightforward algebra, multiplication, division. The more difficult part is figuring out what each variable means in the context of the question, but we'll get more practice with that later on. So to summarize what we talked about today, relative motion has to deal with vector addition. So displacement and velocity, these are things that we are more familiar with in our everyday lives. What's important in this part is drawing diagrams and visualizing the vectors, which we will get more practice with later, and trig functions, as well as the occasional sine and cosine law for math. Special relativity has to do with motion near light speed, and time, length, mass. They all change because of these special circumstances. And what's important in these kind of questions is to know what each variable means in the equations, which again we will get to later. And for math, just algebra. Make sure to know how to solve for the variables. That's it for this video. Thank you all for listening.